US just built a fighter jet that makes missiles disappear. A $3 million missile locked onto your cockpit, traveling at Mach 5, vaporized into thin air centimeters from your wing. Gone. For $1.40. This is the F-47's plasma shield, ionized gas that makes hypersonic missiles physically obsolete. China spent $180 billion building weapons specifically to destroy American jets. The F-47 just made every single one of them useless. Here's exactly how. China's PL-15, Mach 5, 300 kilometers, AESA radar guidance, dual-mode infrared terminal homing, mid-course data link updating in flight. It doesn't just fly, it thinks. Traditional countermeasures are dead. Chaff works against Cold War seekers. The PL-15's AESA guidance identifies and rejects chaff signatures in under 40 milliseconds, before the strips even fully disperse. Flares face the same wall. 2026 infrared missiles use two-color seekers that separate a jet engine's heat signature from a 2,000-degree magnesium decoy. The flare buys 200 milliseconds, that's it. The proof it's already happening in the real world: in the India-Pakistan clashes of June 2025, Chinese PL-15S burned through advanced electronic warfare deployed by a second-tier adversary. China studied every data point from that engagement. The next PL-15 variant is being hardened specifically against jamming. Run the real engagement. F-22 at Mach 1.8. PL-15 launches at 150 kilometers. Impact in 90 seconds. One chaff burst, two flares, one hard defensive break. The missile's guidance corrects for all four inputs in under 2 seconds. The entire US Air Force had been building electronic solutions to a kinetic problem until the F-47. Plasma stealth is not speculation. In March 2025, DARPA confirmed Boeing and Lockheed Martin built X-plane demonstrators with ionized gas management systems as direct F-47 risk reduction. Here's the physics. High-energy emitters built into the F-47's leading edges strip electrons from surrounding air molecules, wrapping the entire airframe in free ions operating at frequencies between 1 and 100 gigahertz. The exact band where Chinese PL-15 and PL-21 guidance systems hunt for targets. That plasma field makes the aircraft's radar cross-section oscillate randomly between 0.0008 and 0.0014 square meters. Smaller than a sparrow, constantly changing. No missile seeker can lock a target that keeps rewriting its own signature. Here's the number that ends the debate. The F-22's best option against an incoming PL-15 is a 9G evasive break, 3.2 full seconds of maximum structural vulnerability before the pilot can recover. The F-47's plasma field response time, 12 milliseconds. That is a 26,600% speed advantage. Not over a human pilot, over the missile's own guidance system, and the plasma doesn't stop at radar defeat. At close-range defensive mode, the F-47's emitters push electron densities above 10 to the power of 13 per cubic centimeter, generating a localized pressure gradient that creates contradictory aerodynamic inputs across the missile's guidance fins simultaneously. The missile doesn't explode, it wobbles. At Mach 5, a 2-degree deviation means missing the target by 40 meters. Here's what Beijing doesn't want you to know. China's own scientists have been trying to build this exact technology. In December 2023, researchers from the Xi'an Aerospace Propulsion Institute, China's biggest aerospace defense contractor, published a paper in the Chinese Journal of Radio Science describing their closed electron beam plasma stealth device. They filed the patents. They published the physics. They know precisely how this works. Their problem? Their device covers one section at a time. The radar dome. The cockpit? Key areas only, because generating a full airframe plasma envelope at 10 to the 13th power electron density requires power generation China hasn't miniaturized for a combat airframe. The F-47's adaptive cycle engine produces 150 kilowatts of surplus power at altitude. China's equivalent, roughly 60 kilowatts. 40% of what full envelope plasma demands. China literally wrote the textbook on this technology. They just can't build what the F-47 already has. The F-47's onboard AI processes 2 million data points per second, reshaping the plasma geometry in real time. Threat inbound at 3 o'clock. Electron density concentrates on that vector in 12 milliseconds, before the missile's own guidance can recalculate. The F-47 costs $300 million per airframe. Critics use that number as proof the program is reckless. The math says it's the cheapest weapon ever deployed. DoD invested $789 million in directed energy in FY 2025. Per engagement cost, $1.40 against a $3 million PL-15, against a $7 million PL-21 hypersonic cruise missile. Now run the Pacific Strike equation. China's standard engagement package against a carrier strike group, 24 PL-15S, 8 PL-21S, Chinese expenditure per wave, $128 million. The F-47's total cost to neutralize that package, under $50, $128 million versus $50. Now zoom out to the full program. China's hypersonic missile development from 2015 to 2025 estimated $47 billion, producing roughly 2,000 deployable DF-17 and PL-21 units. The entire U.S. directed energy program over the same decade, $6.2 billion total. Not per missile. For a system that neutralizes the entire Chinese inventory at $1.40 per shot. China outspent the U.S. by $40 billion and built the exact problem the F-47 solves for pocket change. At formation scale, 4 F-47s create overlapping plasma spheres covering 180 kilometers of airspace. Combined directed energy expenditure, under $200. Against a strike package China spent $250 million to position. The same emitters generating the shield also target enemy radar networks, data links, and satellite guidance infrastructure at ranges exceeding 50 kilometers, degrading the architecture feeding the missiles before they ever leave the rail. China's entire Pacific doctrine runs on one assumption: American aircraft can be saturated into oblivion. The strategy was never to outfight the U.S. Air Force. It was to exhaust it. Launch 847 missiles simultaneously. You're past the mathematical limit of any countermeasure inventory. Win before a pilot can react. The plasma envelope doesn't run out of flares. It doesn't count incoming missiles. It runs on electrons. And electrons scale with power output, not with the number of threats in the air. The saturation doctrine assumes you can exhaust the defender. You cannot exhaust a physics field. According to the Pentagon's December 2025 annual report to Congress, the PLA rocket force now fields the world's largest hypersonic missile inventory, over 400 operational DF-17 airframes, 200 plus PL-21s assigned specifically to carrier strike targeting. Combined sunk cost at unit price, $2.2 billion, before counting the over-the-horizon radar networks, the Beidou satellite targeting architecture, and the 14 dedicated launch brigades built specifically to feed those systems. China's 2026 defense budget is $281 billion. The U.S. spent $6.2 billion total on directed energy over the same decade. China outspent America 45-1 on a missile doctrine the F-47 just retired. Closing that gap requires an entirely new weapons class, directed energy systems capable of penetrating a plasma envelope at combat range. China's directed energy program is 6 to 8 years behind current U.S. capability. The gap isn't in production lines, it's in materials science, adaptive AI control architecture, and power generation miniaturization. Problems no budget can solve on a shortened timeline. The 2028 deployment deadline isn't a suggestion, it's the exact date the Pacific window slams shut. The F-47 reaches full operational readiness 12 months after that window opens. That's not a coincidence. That's a calculated race the US just won before China realized it started. One engineering constraint remains: sustained power draw. Continuous plasma generation at combat electron densities requires 150 kilowatts of continuous output. The F-47's adaptive cycle engine produces that margin at altitude. But engagements exceeding 8 minutes push thermal management toward operational limits. The production variance development budget addresses it directly. The architecture already scales beyond a single airframe. The B-21 Raider's 60-foot weapons bay can house a dedicated directed energy array 2 generations more powerful than the F-47's integrated system. Carrier Strike Group area defense projected at 100-kilometer radius. Airborne command platforms. The doctrine is already written. It is the foundational layer of America's next air warfare architecture. Drop it in the comments. Does China have the industrial base to close the directed energy gap before 2028? Or is it already permanently shut? The best analysis becomes our next full video. Subscribe and see you in our next videos.